Directrix.
Direct, but that doesn't direct again.
Graphically, if I were to draw a parabola where the dotted line indicates the directrix, and the point inside indicates the focus, that means the distance from any point on my parabola to either one of these locations is the same. It doesn't matter which point I choose, the distance will always be identical from any point on the parabola to the focus and to the directrix. No matter what. If it doesn't, then it's not a parabola. Just as a reminder, whenever we're talking about a parabola always has a singular point that has one side matching the other side. Oftentimes, it is either the bottom of the parabola or the top, and it's called the vertex. What's going to be new is the fact that not all of our parabolas are going to open up or down. They can also open sideways. Just because they open sideways does not mean they don't still have a vertex, because they do. The vertex on a parabola have the coordinates HK, and they are also the line of symmetry at the x coordinate. So a lot of this should be review, except for the opening sideways, because we haven't done that before. But the vertex should be review, and the line or axis of symmetry should be review as well. Before we get into actually solving or graphing parabolas, we're going to go ahead and take a look at some information about them and how to write their equations. I will give you a second though to finish all of this. Yes, ma'am.
What are the green and pink lines that are like boxed?
I am just showing you that any point on the graph is equal distance from the focus and from the directrix. So those are just lines going from any point on the parabola, showing the distance from the parabola to the focus is the same as the distance from the parabola to the directrix. They do kind of form a box though, if you really look at it. That was unintentional. Yes, ma'am.
I'm gonna, so that stuff we learned before spring break, so is that going to be on the test? Like rational?
I say we just like.
No, because I gave you guys a quiz over that, didn't I?
Yeah.
Yes.
So it'll be on your final, but we're not going to take a test over it.
Just pitch it to them.
What?
Never talk about
I feel like I'm missing it.
I don't know. I don't remember when we did last.
Nothing happened before spring break. It's just wiped from your memory. Okay, so it sounds like we are done writing and are ready to go ahead and move forward in the notes. Is that true? She's marking you.
You got a chicken foot in a protection zone.
Okay.
Jesus Christ.
So we're going to go ahead and talk about the equations of parabolas. The first thing we're going to identify. Oh, dang it. Just kidding.
Wait, did you say this is a 2-day lesson?
Yes. Top line is 4. So the first form we're going to look at is y equals a times x minus h, sorry, x yeah, x minus h squared plus k. Some people call this the standard form. This is actually technically called the vertex form of a parabola because it's written with the vertex coordinates already kind of outlined, but ready to be picked out. So I will call it the vertex form, but just know that some people call it the standard form. They're wrong. The other form that you can have,
Wow.
I know, right? Is x equals a times y minus k squared plus h. I will move it over a little bit. So those are the two different forms that your parabola can be written in. Of course, we're going to identify other information that is particular to each of those forms. But those are the two forms that you will be writing in today. So the first thing we're going to do is we are going to identify the opening direction or direction of opening for each of these forms. Yes. Yes. Both forms are vertex form. If your equation starts with y equals, that indicates that your parabola is either opening up or it's opening down. That direction of opening is dictated by which value in my equation? Anybody remember? The a.
That's what I said.
So if that a value is positive, then your parabola opens upward. If that a value is negative, your parabola opens downward.
That's 0. No.
It's
Zero.
zero.
0.
Yes.
0.
Oh, so it's not just supposed to be a greater than up.
Should be definitely a is greater than zero.
A is greater than.
Today's the worst Monday. If an equation of y equals indicates an up or down opening of my parabola, which direction do you think an x equals equation is going to open?
Sideways.
Left or right?
From the side.
That also is dictated by my a value. So if that a value is positive, that indicates that my parabola opens to the right. If that a value is negative, it indicates that your parabola opens to the left. The next thing we're going to look for each of these is the vertex. The good news is it's the same on both of them. So my vertex coordinates are always HK, no matter the form that my parabola equation is written in. After vertex, we're going to go ahead and take a look at the axis of symmetry. This is the same as line of symmetry. If my parabola opens up or down, it is the x coordinate of my center that is the line of symmetry. If my parabola opens side to side, it is the y coordinate of my center that indicates the line of symmetry. We have two more and then we're done. Well, yeah, I meant two more on the table and then the table's on. We have lots of examples.
Maybe like 5, 6.
I think maybe 6, maybe.
I like the fire drill kind of made this nice stuff. I don't know why, I just kind of made.
Sorry.
You know what?
So sorry. Okay, so when we talked,
We took it seriously though, because we have so
How about this?
you should always take it seriously.
Yeah. We don't know if we're gonna die.
You should take life serious.
When we talked about what made a parabola, what two pieces from the graph did we focus on? Focus and the directrix. Ladies and gentlemen, the focus and the directrix are two of the most important parts of every parabola. So those are the last two pieces that are going to go on your table. The first one is the focus. So this is the point that all of the points on your parabola are equal distance from compared to the directrix. So if I have a vertical parabola, so a parabola that opens up or down, my focus is at the point h, comma k plus 1 over 4a. So if it is a vertical parabola, the focus has the same x-coordinate as my center, but my y-coordinate is changed by adding 1 over 4a to it. If it is a horizontal parabola, so opening either left or right, it is the x-coordinate that changes. So it's h plus 1 over 4a, comma, k. And then the last little piece we are going to do is the directrix. If it is a vertical parabola, that directrix is at y equals k minus 1 over 4a. If it is a vertical, or not a vertical, a horizontal parabola, I can't talk. It is at x equals h minus 1 over 4a.
Oh, wait a minute.
It's not. Focus is coordinates, directrix is a line. And then that is all the information that we're putting into our table. So that is all the important information that we need to know about a parabola. Yes. Yeah. You're welcome. And I will give you guys a second to finish writing that, and then we'll start with an example. But I know you're all super excited.
I love that.
There are 6 examples in the notes. We're probably not going to do all 6, and we're done today. It's a 2-day lesson. That was always my intention.
4-day lesson?
No.
Sorry, I had to do this.
I'm down too. I don't want to do anything Wednesday.
No one wants to do anything.
I mean, especially no math that day.
I never said we were doing another lesson on Wednesday
Oh
either.
my God.
You're doing it in a.
After we're done. Okay, so it sounds like we're done, so we can go ahead and start our first example.
Turn it into like a little like hanging plant.
I thought you just made a smiley face. I didn't see the example part of it. Really awesome. Well, all I saw was like a dot flower. Now it's like one of the lines. Yeah.
Destructive.
Now I can't write those. I can't write food to eat. You have to bring it up. And then chop. How his mouth is doing that. You can use that as a half and then I'll do that. Why are you
Ask her later.
So much energy.
So our first example asks us to write this equation in vertex form, and then to also identify the vertex, the axis of symmetry, and the direction of opening of this particular parabola. I will give you a second to finish writing.
How was your weekend?
Not long enough. How about yours, Mr. Van Aswell?
Uh,
Not great, right?
It was, did you see Andrew's
I did. I'm so sorry.
location? So one of these days, Miss Grant, I might not.
That's fine. Just let me know. Okay. You guys are very not, I don't know.
How we get today?
Yeah.
Oh, I'm gonna stop right here. I didn't get my nap in time.
Really feeling that now.
I think we can stop after this example and we rest tomorrow.
Okay.
Oh my
Ladies and gentlemen, what is my end goal for this particular example?
Make it a problem.
To find the vertex form and identify specific information. So I need to find a way to take this quadratic and turn it into vertex form, which means I'm gonna have to have some factor squared. Who has an idea of how we're gonna do this?
Distribute.
Nope,
Oh, rainbow.
nope, nope,
The x plus x minus.
Do some crazy.
nope.
The thingy. The parentheses, the x plus 2, x
Cancel out the
plus
x
2.
squared.
That thing, what that's called.
I can only make this low factor.
We are going to complete the square,
I knew it.
which is what we did before. I apologize, I did not hear you.
I was explaining.
So in order to complete the square, the first thing I need to do is what?
You need to 2 times 6.
Nope, that's factoring. I'm not factoring.
Divided by 2.
Nope,
Oh.
I need to move my constant. So I need to move this
Really?
over to the left-hand side. When I do, I'm left with y minus 6 equals 2x squared minus 12x. I know that when I complete the square, my goal is to add in a third value into my quadratic that will make it factor into the same thing twice. In order to do that, my x squared first has to be by itself. It can't have a number attached to it. So what am I going to do with that 2 that's attached to my x squared?
Take it off.
We're going to factor it out. We're not necessarily going to divide everything by 2 because then that would leave me with y over 2 and that's not going to help. But I am going to factor out a 2 from both of these x terms that are left on the right-hand side. When I do that, I'm left with y minus 6 equals 2 times x squared minus 6x plus the unknown constant that I'm going to fill in. I added a constant to the right, so I also have to add that constant to the left. But when I add it, what has to attach to it? The 2. So I also have to add 2c1 to the left-hand side to keep it in balance. Now here's the real question. How do I find that constant c1? And then, correct. So we go to the value in front of c1. Here that's negative 6. I take that negative 6, I split it in half, and I square my answer. So negative 6 divided by 2 is negative 3. Negative 3 squared is, so my c1 value here is 9. So I'm just going to go ahead and fill that in. I get 2 times 9 plus y minus 6 equals 2 times x squared minus 6x plus 9.
Can you slow down?
Yes, I will pause right here.
The normal thing that we did last time,
Mhm.
and then the normal thing.
Are we having fun yet?
I think I'm writing down the numbers.
Oh, this is fun.
It's not awful, but it's not the ideal
Also, it's not like
situation.
like this.
No, that's very tempting, but then I think about all the things that we still need to do, and then it's a little less tempting.
Hey, Mr. Ray, can we go outside tomorrow? Because it's gonna be 80.
I have sent an email asking that very question.
Did you get my email?
I did. That's why I sent an email asking that very question.
And we'll be like, Mr. Barnes, if you don't let us go outside, we will intentionally fail the
I mean,
class.
we
and
all
won't get
can.
money.
Okay, ladies and gentlemen, coming back together. What do I do next?
Adam,
Add what, Alex?
the whole thing.
No.
You can do 2 times 9,
Okay, and what can I do with that 2 times 9?
put it in the equation.
Better question. What is 2 times 9, Alex?
18.
Can I not combine it with the -6 that's also on the left-hand side?
Good.
And what do I get when I do that?
12.
Awesome. So now my left-hand side is y plus 12.
Distribute.
No, I do not want to distribute. That's the exact opposite of what I want to do.
Why not?
Because my vertex form has x plus something squared or x minus something squared. So I need to get that into a factored form. Reese, how am I going to do that? You don't know how to factor? Come on. I'm looking for 2 numbers, what and also what? Nope, opposite. Positive 9, right? Okay, so Reese is gonna say that again, and then you guys are gonna find the numbers. Reese. Okay, so we're looking for 2 numbers that multiply together to get 9, but add to get -6. What else do I know about these numbers? They're the same, and they will be the same because I made it so they will be. So what number times itself equals 9, but plus itself equals -6? Perfect, so this factors into 2 times x minus 3 squared. I am almost in vertex form. What is the last piece that I'm missing? Move the 12 back over. In both of those vertex forms, the left side was by itself. So I get y equals 2 times the quantity x minus 3 squared minus 12. Yes, me.
Okay, what if you don't have like a number for the experiment? Would you still like run with it?
You would still complete the square like normal. We just wouldn't have this value here. Yes. Okay, Alex, what are the coordinates for the center of my parabola? And by center, I mean vertex.
Well, let's see. You gotta do HK.
Okay, so what's my h value here?
-3.
No,
You're what?
it's the opposite of that.
-12. 3.
3. My h value is the opposite of the number attached to my
I
x.
knew that,
But you said -3.
but I was.
So that is +3. This is where it's different than everything else we've done. My y value is that last number exactly how it is. So my y or my k here is -12.
This is really gonna be confusing in future.
Yes, it is. Madison.
Is it like that because it's not attached to a y?
Yes, it is like that because it's not currently attached to the y. So if we left it as y plus 12, then I still would have taken the opposite and it still would have come out to -12. So if you want to leave it like this, technically this is a form of vertex form. And if you wanted to, that would be fine. But this is how they prefer that we write parabola equations. So our vertex is 3, -12. That is one of the things that it asked me to find. What's the other, one of the other things it asked me to find?
Form of equation.
Axis of symmetry. How do I find my axis of symmetry here? X equals h. What's my h value?
Your H is gotta be. That's 3.
It is 3. It is x equals 3. How did I know that it was the x equals h and not the y equals k?
The chart.
That's
Because the Y equals 2 instead of the X equals.
So my vertex form is y equals, which means it's a vertical, and verticals have a x equals line of symmetry. And then what's the last piece that it asks for? Direction of opening. How do I figure that out?
A thingamabobber, zero,
A bigger, a
upward.
Right. So I know I'm comparing a to 0, but what is my a value here? 2. What if there was no number in front of my parentheses?
0.
1.
Zero.
What?
If there's nothing in front of the parentheses, we assume it's a 1.
Wait, which one's A? Because 0 times that would be 0.
Right. This right here is A. The number in front of my parentheses is A. So my A here is 2. 2 is positive, so this opens up.
Oh.
2 is open.
Yes, ma'am.
It's too tired.
Because it's positive.
Because it's positive,
But hold on. Where did that A come from?
it
I know how
Our
it got
original
there, but how do
equations.
you know
A's
the
just-
A was OG? What was it originally, or did it just show up? Where did
The
it
numbers is what you plug into the equation.
like, how did I get the 2 out front?
I
Or
don't know how it got there, but why is it A? Or is it just
because in both of the equations, any number in front of the parentheses is my A. Okay, how do we feel about this so far? Icky? 1, 2, okay. We are gonna do another example before I ask you to self-evaluate, and then I think we're gonna go ahead and be done
Wait, what?
for today. We're gonna do one more example, and then we're gonna be done for today. I think I've thoroughly fried your brains. Yes. Can you wait until this last example?
You giving that one?
This one is a graphing one, yes.
You're gonna have to wait.
I have insomnia, Melinda. I forgot to take my medicine last night. Is this something I
Yes, we can. Okay, are we ready? Maybe, hopefully.
You're born to hell.
Awesome, okay.
Let's take the 4y to the other side,
Why would you decide to take the 4y to the other side, Alex?
because it matches with all the other stuff, and that tends to
Okay. So it matches, but it's not identical to everything on the left, right? What is over on the left is a y squared. But what do I notice is missing from this left-hand side, or from the whole equation in general?
X squared.
An x squared. Because there is no x squared, x is what I'm trying to solve for, because there's no way I can complete the square without an x squared. So it can't possibly be something that exists on the right-hand side. So actually what I want to do is I'm going to start by moving the y squared to the other side. When I do, I get y squared plus 4y plus 10 on the right and 2x on the left. So all I did was I moved the y squared. What do you think we should do next?
Is it this?
We should
This side
take care of, try to.
No, I was too scratched.
No, we can't factor it yet because that's not a perfect square trinomial.
Yeah, just with the square.
Add us in. Subtract the 10 to the left and then complete the squares with the y's. So I'm going to subtract the 10 over. Then I'm going to go ahead and add in a C1 on the left. I'm also going to have to add the C1 on the right. Well, actually vice versa, but same thing. I know that the right-hand side is a quadratic that I need to create a perfect square for as my third term. That'll make it factor beautifully. So how do I find that C1 that's going to go in on the right-hand side to complete that quadratic? 4 divided by 2 and square it. What's 4 divided by 2? What's 2 squared? So my C1 value is 4. Filling that into both sides. I get 2x minus 10 plus 4 equals y squared plus 4y plus 4. Of course, I know I can simplify the left-hand side. Negative 10 plus 4 is negative 6. What am I going to do on the right-hand side? Factor it. What's it going to factor into? Y plus 2, y plus 2, which is just y plus 2 squared. It is a y and not an x. Make sure you're paying attention to that part. So now what I need to do is I just need to finish getting my x by itself. I'm going to start by adding the 6 back over to the right-hand side. Couldn't have left it there because then I couldn't have completed the square. I have a little bit of an issue. My x is almost by itself, but what's attached to it is attached by multiplication, which means the only way to get rid of it is to divide it out. If I divide both sides by 2, I'm going to end up with a fraction in front of this parentheses. Is that okay?
No.
Yes, it is.
What?
Yes. A fraction is still a number, so it is 100% okay.
Fractions are not numbers.
So I'm going to go ahead and divide that 2 out of everything. Those cancel. I can't really take a parentheses and divide it by 2. So this is the same as 1/2 times that parentheses.
Wait a minute.
And then 6 divided by 2 is 3. I will pause here for a second.
The 1. I know we don't.
Same as dividing it by 2. I just wrote it as 1/2 because that gives me an a value.
Oh, because you can just.
Yes, it would be.
That's how math works.
It is.
That's terrible.
Thanks for that, Shane.
I have nothing against you, Fran. You're a great person.
Thank you.
But math sucks. I just got praise almighty shit.
Okay, so I know the instructions here said that I had to graph it. You should know that when I ask you to graph something, there are actually 5 things that we need to find first. The first thing that we need to find is the vertex. The second thing that we need to find is our axis of symmetry. Then we need to indicate the direction in which it opens.
I have a question.
1 second. I also need to find the focus, and then I also need to find the directrix. What is your question, Jane?
Will we have to figure all those out, or will the question ask us, like, find the vertex or the...
If I'm asking you to graph it, I expect you to find all 5. If I'm just asking for like the vertex and the axis, it's just whatever I ask for.
All right.
You won't always have to find all 5 of these. Yes, Sam.
You don't know like a specific order. Is it okay that like?
They can be out of order, yes.
I don't know,
Yeah.
like,
This is honestly just the way I kind of move through it. So this makes sense, but if you want it in a different order, that's fine. That's perfectly fine. Okay, so we're gonna go ahead and start with what is arguably the most important, and that's the vertex of my parabola. What is the vertex for this parabola? Say that again, Madison. You guys agree with her?
No.
How many of you think it's -2, 3?
I'm not.
How many of you think it's 3, -2? Is that x plus 2 or is it y plus 2?
Why?
Which means
Wait, what?
that this is a horizontal and my vertex, the ordering's a little bit different. So Madison was correct. This value out here is actually my h value, and the value inside is actually my k value. I know this because it's y plus 2, which means the 2 is attached to the y, which can only make it a k value. That was a very, very good observation. You had the right numbers, just make sure you have the order correct as well.
Where's the rule with the order? It just says H.
It does, but look at where the h and the k are placed in that second equation. Yes. Okay, so we found the vertex. Logically, the next thing I can identify is my axis of symmetry because it comes directly from my vertex. We already noted that this is an x equals equation, which means it's horizontal, which also means that my axis of symmetry is y equals something. So what does y equal here for my line of symmetry? K, what's my k value? -2. So we found the vertex and we found the axis or line of symmetry. Everyone okay so far?
Of course not.
AOS.
That's axis of symmetry or line of symmetry. I just get tired of writing it out every time. Okay, found the vertex, found the line. How do I figure out direction of opening? It's the A. First, I know that this is horizontal, so it's either going to open left or it's going to open right. That A value is what number? 1/2. Is 1/2 bigger than 0 or less than 0? Bigger than 0 because it's positive, which means that my parabola opens which direction?
Right.
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 Oh, I see this one. You definitely said right. I did not see you doing it. Yes. Yeah, which is my right. Which is my right.
Now we have the extremely fun parts. Those are the focus and the directrix. These are going to come directly from that table that we wrote down already. I know that this is a horizontal parabola, so I'm using that rightmost column. My focus then is my h value with 1/4a added to it. So I'm going to start there. My h value is 3 plus 1/4 times my a value, which is 1/2. And then my k value stays the same. A fraction and a fraction. 4 times 1/2, yes.
Why?
Because it's 4 times my a value, and my a value is 1/2.
Oh, it's just. That's so funny.
And then, of course, we can simplify it. So I know that 4 times 1/2 is what? 2. So then this is the same as 3 plus 1/2, -2. And 3 plus 1/2 as a decimal would just be 3.5. So that means my focus is at the point 3.5, -2. We have one last piece and then we are finished. Well, and then graphing it, but that's easy. And this is the directrix. Again, I know this is a horizontal parabola, so I'm using that rightmost column. That rightmost column tells me that my directrix starts with x equals. X equals, yep, h minus 1/4a. My h value is 3 minus 1/4 times 1/2. I know 4 times 1/2 is 2, so this is the same as 3 minus 1/2, which equals what? 2.5. So x equals 2.5 is the directrix for this parabola. So now the last piece here is that I just get to go ahead and put all of this information on the graph. I can tell you right now that when I'm asking you to graph this, the only point on the parabola itself that you actually need to put down is the vertex. From there, we're just going to approximate what the rest of the shape looks like based off the direction. I'm not asking you to find 5 additional points to put on here because that's just redundant at this point. I'm looking for all of this other information instead. Okay, so going ahead and graphing this, I of course have my coordinate plane. I always put down my axis of symmetry first, and my axis of symmetry exists at y equals -2. So that's the first line I go ahead and put down, and I always make it dotted. After I put down my line of symmetry, I like to go ahead and put my vertex down. So my vertex exists at 3, -2. So I go to 3 on my x-axis, I go down to -2 on my y, and I put my point. The next things I need to put down are the focus and the directrix, and then I approximate the shape of my parabola. My focus is at 3.5, -2. So I go just a little bit past, or not a little bit, halfway between 3 and 4, and I go down to -2. I like to put an X on my focus. That way I can tell it's different than my vertex. And then I will go ahead and put my line that is my directrix. And this directrix is at x equals 2.5. So on my x-axis, I go halfway between 2 and 3, and I put a dotted line. Once I have those, I can go ahead and approximate the shape of my graph. I know that my graph opens which way? Right. You should never, ever cross your directrix. If you did, you graphed it wrong. Okay, so then we can just go ahead and draw the approximate shape. I will ask you guys to 1 to 5 it. I do want to know how you're feeling so far. And then the rest of class is homework time. I don't think there's a ton of time left, but that's okay. So 1 to 5, how are we feeling about parabolas?
That sucks.
Hey, you know, I'm not seeing as many 2s as I thought I was going to see. So that's good. So the rest of the class is work time. You only have a couple minutes left, so it's not worth it. Tomorrow we will finish these examples. And then Wednesday is going to be a work day, primarily because you guys could use it after this. And then we will go into hyperbolas.
Good job.